Hello guys, here we are at Code Rage 11. Today we're going to talk about Arduino plus mobile apps. You will choose between Delphi or C++ Builder, and today we're going to go all through the basics and a little bit beyond the basics on how to integrate these apps with Arduino and control everything Arduino has to give to you via your app. Well, this presentation was originally done at IT-DevCon in Italy last October, and my name is Victor Fernandes. I'm Embarcadeiro MVP in Brazil. I'm also an electrical engineer with a master's degree in medicine neuroscience, working as a CTO at tkssoftware.com. Well, I live in Salvador, Bahia, which is a very nice place to live and to be at. So let me tell you a little bit of my personal life. When I was at the university, I was very young, around 19 years old. I once visited a hydroelectric plant, and I was very impressed about the size of the structures and how the engineers were able to control everything from the main control room. On that day, I asked the guy, okay, if I want to open the gate and make the water flow, what should I do from here? And he said, okay, I just need a couple of clicks. And with nothing more than 3 or 4 clicks, he told me, okay, from now on, if I want to go further, I have to type a password and things will actually happen outside. And from that day, I decided what I wanted to do. I wanted to be able to develop software that could make things happen outside my computer. Not only network applications, database application, forms, and so on. I wanted to control things, to read sensors, to actually make things happen in the real world from a click of a mouse. So a good approach is to try to look at things and make them look simpler. If we consider those big gates, okay, it's very hard to understand right now all the electronics involved in opening or closing them. But we may consider something simpler. We may consider, like, for example, a lamp in your room or office. Do I have all the knowledge involved to light up a lamp from an application? Well, I do know how to do software like in Delphi or C++ for my mobile or computer, but am I able to light up this lamp? In most cases, you will most probably say, no, I don't. So we can think even simpler. Okay, I don't want to light up a lamp. Can I light up a LED? If we consider the electronics, we have different level of electronics involved in each of these 3 cases. But if we consider the logic is absolutely the same. The light is going to be on and off. The gate is going to be open or closed. So from the application logic, we can control these things with the very same click of a button. So if I'm able to control them from my application, I may only need some electronics to jump from one level to the other. So let's start from the simple point of a LED, and then we may at some point get to the big gates. So at the IT-DevCon event, I had the opportunity to ask the guys, who here has ever worked with microcontrollers before? And some people raised their hands, and I was able to talk to them and understand how they have worked with microcontrollers and what kind of applications they have developed. So here I want to give you guys 2 examples of my real life usage for microcontrollers. Okay, first one is my master degree work. We developed a portable medical electrical equipment where we were able to track Parkinson's disease tremor. So the idea here was to have a embed board with a accelerometer sensor attached to it, and we would have a software tracking the tremor and presenting the results in a graphic screen like this. And here we can see X, Y, and Z axis, so the tremor is clearly going up at some point the patient may take his medicine and the tremor starts to go down and stays like this for, let's say, 3 hours, and at some point it starts to go up. With a graphic like this, a doctor can actually work on better results for the treatment and track on results and stuff like that. So another example is this production tracking system we once found in a factory floor application. So here we had 3 lamps, green, yellow, and red, for each of the production lines. So he could check on production line results and see that this production line was working in a not very good status. Yellow status for them was not very good, red was a problem, green was okay. But the problem is that they had no database of historical information for the production tracking system. They had to actually look and be physically present on this room to check on the status of the production. So the idea here was to attach a box with some electronics and track these signals, now storing everything on a database and presenting the very same status. You see here yellow, yellow, the very same status on a TV. And now we could have TVs all around the factory with the very same information. And we had this implementation done with a TOS interweb, so we could actually see the very same information on a device running on Wi-Fi or internet if they have their firewall programmed. Now we also had SMS to set up alarms and stuff like that. So this is how we could use electronics in the real world and make some very simple but useful things integrating, let's say, Arduino or any kind of microcontroller with your software development. If you're new to this microcontroller world, I suggest you consider Arduino as a starting point. Please check www.arduino.cc and www.arduino.org website and consider the Arduino Uno as your starting point. This is by far the cheapest and easiest board to start with microcontrollers programming nowadays. Well, Arduino has a very interesting and powerful concept which is called shields. Let's understand a little bit what is the shield concept. I want to make a card tracking system. In this case, I would use a GPS shield on top of the Arduino Uno board. And I would upload a software to my Arduino Uno board that would go something like this. Okay, every 1 minute you should request the GPS coordinates to the GPS shield, and you should try to send these coordinates via standard GSM mobile network. Of course, I would need a GSM shield on top of my GPS shield. And after you try to send this message, if the server does not reply to you saying, okay, I got your request, I got your coordinates, and you should try to store these coordinates on a SD card with an additional SD shield on top of the 2 shields we already have. So we just go plugging shield on top of shield, and we could use RHTStudio, Delphi, or C++ Builder to develop our server. The thing is, we are very good on this side, the Delphi or C++ Builder application development, but we are not very good in all the electronics involved to do all this GPS, GSM, SD card communication. Now I have someone that developed shields for each application that I can just plug them together as I may need. So at the end, we used here in our company the TOS interweb solution to develop a real-time vehicle tracking system running on top of a browser, in this case here Mozilla Firefox, and everything works perfectly. So this is how you guys may be looking right now, okay? Just a little fun. So where do I get to know about Shoots? Please check on www.shootslist.org, and when you open the website, you'll see a list of manufacturers. Let's take, for example, the SparkFun manufacturer. SparkFun is an American company, very good in shields. They have here like 24 shields available. And if I click on SparkFun, I'll see that they have GPS, microSD, and GSM shields available. So they do have everything I need in one point. I can go there, buy the shields I need, or just click for some more information. But let's say I don't want to buy SparkFun, or I don't know previously that they do have all these three things. I can just use the search box to type GPS, GSM, SD card, and look for manufacturers that have these kind of shields, and also compare the shields prices and so on. So this is a very powerful website that you will find a lot of information in some very useful shields. So let's take a look of what kind of shields I'm talking about. So let's say you need to work with video applications. You can use, for example, Gameduino with VGA output and stereo audio, so you can connect on your TV and actually make your own video game. We also have, for example, boards with NTSC and PAL support. And if you are developing your own video game, you may need joysticks, right? So here we have the very same joysticks we can find on PlayStation and so on. And they are very simple to use. 2 buttons, 4 buttons, you'll choose what you need. Let's say you need sound support, then you have boards for MP3, you have boards for stereo to voice applications. If you need a display, you can count on very simple 7 segments display boards, or you can have like more detailed 16 characters, 2 lines of information like this one, or even colored LCDs with third support and so on. If you want to control motors, you can count on H-breeds, simple ones for 1 ampere, 2 ampere, and many others. If you want to connect on a network, you can use Ethernet cable or Wi-Fi using this kind of shields. And this is the one we're going to use here. We're going to communicate our mobile app via Wi-Fi with a hub or with some kind of router that goes on cabling to our Arduino. So we're going to use this guy here to control the Arduino. And here we have like storage shields with microSD, SD cards, and many others. If you want to go into automation, you can use CAN bus to communicate on factory networks, or even use relays to control 220 volts of alternate current, very easy. Or even other kind of networks like ZigBee, Z-Wave, and many others. If you don't find the shield you need, okay, no problem. You can use like protoboard shields to make yourself the shield, the electronics you need, or even standard boards like this one. So at the end, if you don't find what you need, you can build it yourself, and you can even sell your own boards as components in the shieldlist.org website. Okay, check on yourself now, okay? So, if you start with the Arduino Uno concept, you'll see that it's not a very small board. So no problem, you can go now for Arduino Mini, Arduino Micro, Arduino Nano, which has the very same software support. I mean, the very same software you program for the Arduino Uno board, then you can use with just some variants on number of pins and stuff like that in smaller boards. And then you can now go for smaller projects, okay? Well, there's another very nice advantage is the use of Arduino LilyPad for wearable projects. Now you can do amazing things like this t-shirt here, which is very funny. It shows you how many unread emails you have in your mailbox, okay? Just for fun, but then you can work with like more functional applications. So let's do a first Hello World application with our microcontroller using Arduino board. So most microcontrollers, they will not have a formal way to know if the software that you uploaded to it is running or not. So how can I know if my software, my first software, is actually running in the board? So this is how we usually do our first Hello World. So here I have connected a LED in the pin 9 all the way through the pin ground. So what happens is that if I have an application running that will say, okay, pin 9, please go to logic level high or logic level 1, then 5 volts voltage will appear between pin 9 and the ground, and the LED is going to turn on. If my software says, okay, now pin 9, you have to go to logic level number 0 or low, this 5 voltage will go off, then we'll have 0 volts here between these two pins, and the LED is going to go off. So this is how our first Hello World is done, and we usually will work with proto boards, some piece of wire to put things together like this, and this is how it looks like in the real world application. Okay, very simple components you can find in any website or electronic store very close to you. So let's take a look at our first Arduino C code. Most microcontrollers are programmed in assembler or C, and in the case of Arduino we have a specific compiler which supports C. And well, here we can go into File, Examples, Basics, Blink. Here we have many examples, and if we check on the Blink example, we will see that we have a setup function. This is the very first function that is executed every time you run your program, you power up your board. And in the very first line we have pin mode, LED built-in output. Okay, I will just change this LED built-in for pin 9, and I can say pin mode, number of the pin 9 is an output. So we have several pins that can work as input and output, and in this case I'm setting up pin 9 as an output because I have attached a LED to the pin 9, remember? Now we have then a void loop. The void loop is an infinite loop that runs until you power off your board, and in this case we're going to do a digital write. So we're going to write a digital value into a certain pin. In this case I'm going to use pin 9, okay, and I'm going to set high in the pin 9. Then I will wait 1000 milliseconds, so I'm going to wait 1 second actually with the pin 9 in level high. After that I will write a digital value into the pin 9 again of low, and I will wait 1 second again, and then the loop goes on. So here I have a Blink example that goes on and off for 1 second in each level. Okay, well, remember this LED built-in. Okay, we will come back to this constant later. Very easy. This is our first program. If you upload this program to your Arduino board and you use this circuit here, you'll see the LED going on and off. Well, now I'm going to give you a very nice suggestion. is for you to use the Hobocore Padawan board, which is a board that comes with a RGB LED. Okay, we also have potentiometers, we have light sensors, temperature sensors, we have a display here, we have a output that we can connect other things here. So it's a very nice board. And in this case, when I traveled to Italy, I wanted to show a LED, but I did not want to use a circuit like this because I went from Brazil to Italy, and this is not something that we can trust. So I used this RGB LED system from this Hobocore Padawan board in Italy. And there is another version that I want to introduce to you guys, and we're going to use this kind of boards in our demos today, is the DF Robot board. We also have a RGB LED here, but we have sound, we have relays, joysticks, and some other things that we are going to investigate later. Okay, we have the links here so you can check on it later. Well, you remember I told you that we would go back in the built-in LED constant from the Arduino we have just done here. We had like pin 9, we had LED built-in here. So when I refer to this constant, I'm actually referring to this LED on pin 13 that comes in the Arduino board itself. So you can work with that in case you want to just test or give some status from your application, okay? So the idea now is to have an Android or iOS application that is able to send commands on any kind of network. In this case, we're going to use Wi-Fi and Ethernet cable network to an Arduino board, and is able to actually control all the input and outputs pins from this board. The idea here is to upload a software that behaves as a UDP server and runs on a certain IP address and port. You will be able to change this as you want, and is able to check on messages. So let's say your application here on the mobile device sends the letter 8 for, let's say, high level, level high, level 1. We want the LED to go on. And if it sends the character L for low, logic level 0, we want the LED to go off. So this is how we are going to establish our first control protocol from scratch on Arduino. And to do that, we're going to check again on the Arduino board, and let me open here, file, examples, Ethernet, UDP, send, receive string. So this is the software, the C code that's going to be compiled and uploaded to your Arduino in order to do what we want to, process the 8 and L characters. So the original code that comes in Arduino enables you to change the IP address to whatever number you want for your network and change the UDP server port, okay? After that, we have a setup that configures the Ethernet shield board, and this application here actually behaves as an echo application. So whatever you receive, so you receive a packet, it stores the packet size. If packet size is bigger than 0, then it checks, it prints for you the packet size itself and from whom the packet came from. And we can like send back the same buffer received, we can send back to the sender. So if they send A, the application on Arduino replies A. If it sends B, it replies B. Very simple code. The idea is to start from this code and make some few changes so it can work as we want to. So what we're going to do, we're going to check on this example, and on the setup a part of our application, I want you guys to add this line of code, pin mode 9 output. So we are configuring the pin number 9 as an output. Remember, we put a LED on pin number 9. So after that, we're going to check on packet buffer character number 0. So if the character number 0 is a H letter, we're going to send digital write message to pin 9, establishing the pin as high level. If it's not equal to 8, we're going to test if it's equal to L. So if the L character arrives, we're going to set pin 9 to low logic level. With this couple of lines of code, so we have 4 lines here plus 1 here, so 5 lines of code, we are able to actually compile and upload a software to Arduino that now responds to strings H and L, so it can actually control the pin number 9 remotely from any mobile device application that can be developed as a UDP client. So all we have to do now is compile that application, upload to Arduino, and then we have to develop the client side, which will be made in Delphi or C++ Builder. Little jump now. Here we are with Delphi open, and we're going to create our new application on the client side. So the idea is to go in File, New, Multi-Device Application. We're going to choose a blank application, and as we want to create a ID UDP, an UDP client, we are going to choose the ID UDP client component, and we're going to put here in the host property the IP address that we have configured in our Arduino board, and the port we have configured also in our Arduino board. So here we are, and we can put 2 buttons here. We are going to put a button 1, which is going to be called on, and a button 2 that's going to be called off. Okay, now we're going to add some code here. ID UDP client 1 dot send, and we're going to send the character 8. Let me copy this, and we are going to send the character L to set the LED to low. And now we are going to compile and run our application. And the good part is that this is a FireMonkey application, so I can compile and run it on the Mac side. You see here, my application is running on the Mac side. I can also compile and run it on the Windows side. And the very same application can be compiled and run in iOS and Android, and it's going to be an UDP client that is going to connect via Ethernet with my board and control the LED. Okay, so let me try to show you guys here my workspace. So here we have the Arduino board. Down here we have here the Ethernet shield with a Catch 5e plugged in. I have here on the other side, you see here, my router, my wireless router, and on top of it I have this Robocore shield that you can see here, lamp and everything I need to run my tests. So I'm going to open here also my mirror so you can see the screen on my iPhone. You see here I have plenty of demos. I'm going to run this demo here, which is called RGB LED. It's a very simple demo, and I have 3 colors in the LED, so I can light up the blue one. You see here, the blue one is on. Turn it off, light up the red one, and light up the green one. So I'm clicking the buttons, and things are happening in my board. Let me see if you can see here. Let me click here. It's going to be hard. Okay, here you are. You see, blue, red, and green. See? So very simple. Just a couple of lines of code, and now we are controlling 3 LEDs on our board. So let's keep it up. 1 second, and let's go back to our presentation here. So this is the C code that we need. We have seen here this LED demo app, very simple. And now you feel like a ninja, right? I'm clicking buttons, and via wireless, I'm making things happening in my board with 5 lines of code of C in the Arduino side, and 2-3 lines of code in the C++ or Delphi side. So we are now controlling a LED, and the LED is 5 volts of direct current. So it's very easy to integrate with our board because our board outputs a 5-volt voltage, so we can just plug them together and it works. And now I want to light up a lamp. I want to control the lamp in my office. I want to control the lamp in my room. How can I do that? Because now I have only 5 volts of direct current going outside the board, the Arduino board, but I need 110 or 220, depending on where you are, of voltage, but of alternate current to light up a real lamp. So what we can do now is go a little bit into electronics. So let's see how the magic is done. Let's take as an example, this is standard light switch example. So in our office or home, we have a light switch in the wall, and we have to use our finger to mechanically press the button. When we press the button, the circuit is closed, and if the circuit is closed, the current can go all the way from the power source through the lamp, and then the lamp goes on. The thing is, I need some kind of device that makes it possible to close this circuit without the need to use my finger. I need to not mechanically close the circuit, but electronically close it via software or via my Arduino application. So how can we do that? We can use relays. These are simple relays, and they have coils inside of it. If you study a little bit of electronics, you know that if we have a coil and we apply some voltage, there's going to be a current, and when the current shows up inside a coil, there is a magnetic field that shows. So if we have a magnetic field, it's going to attract this switch here from this point to this point. So if I apply a low voltage, let's say 5 volts, 12 volts of direct current in this side, I'm going to bring this switch from here to here. And if this voltage goes off, the switch will come back from here to here. So it's going to move electronically without the need to use your finger. The good part is that between this side, these terminals on this side, we can apply higher voltages of alternate current. So we can actually light up a lamp using a very small relay like this one. So we can use relay modules such as this one from HoloCore or this one from DFRobot. They're all Arduino compatible, very cheap. And we can connect them to Arduino using a simple circuit like this one. We just plug the power source in this pin here and the ground source here. And we need an additional pin to control the state of the lamp, on or off. So our software running the Arduino board is going to send commands of high and low logic state to pin 13. It's going to control the state of the switch inside the relay to turn on and off the lamp. And in this case, we need, of course, the power source and the lamp to be connected to our module. So let's see a simple application running in our mobile. Now let me show you the mirror. Here I have my cell phone, and let me open my camera. Here I have my camera. Let's go back to my module here on my table. Sorry, it's a little bit difficult to put everything together. And if you check here, it's my daughter. I have this lamp example. I'm going to open it. And the only reason that I have a different application from the LED is that now I have a different interface that I can, let me show you here, that I can click on my cell phone and the lamp goes on. I can click again and the lamp goes off. So I have a different interface. I wanted it to be something better for you guys to see the results. Okay, but it's exactly the same, the very same command lines that I sent to light up the LED. I'm just sending 8 for level high or L for level low, and the LED is going on and off, and now the lamp with the use of the relay is going on and off. So very simple way, and now we're feeling like ninjas. Let me show you a real life application for this. So this is me, and this is the main door for my office. Whenever I get to my office front door, I am already connected to the Wi-Fi on my mobile device. So I just use this very simple application here to unlock the main door. It's the very same code I just demonstrated to you guys that is able to light up the lamp. Because the lamp is on or off here, I just send a pulse and the door unlocks. So if with a very simple code, few lines of code, we are already making useful things. I suggested you guys to work with the HomeCore Padawan board. This is the one I'm using here, the one I demonstrated to you guys. We have already played with the RGB LED, and I actually connected the relay module to this general pin connector here. But I also have a light sensor, I have a temperature sensor, and a display and a potentiometer here. You can also work with DF Robot accessory board that comes with pressure humidity sensor, a buzzer, a LCD display, a joystick, the same RGB LED I have in the other board, a potentiometer, and a relay. In this case, you can light up your lamp directly from here. The idea of these boards is that they come with many different things that makes it possible for you to start from scratch and have a small lab on your hands before you start to go a little bit further in the electronics. Okay, but until now our protocol can only control like one pin. We did like 5 lines of code in the original C Arduino code, and well, we could only do things with 1 pin or 2. Let's say it's not possible to control all the pins, but we want to be ninjas, right? So it's time to go a little bit deeper into the Arduino code and make a better code that is actually able to control all the pins, outputs and inputs of the Arduino. So what I suggest to you guys is the following. Let's say I want to control the pin number 4 and send a digital write message of a value high. So we suggested a string protocol. Digital write 04 is the pin, H is the value I want to send to pin 4. Digital read, if you want to read a digital value, in what pin? Pin 2. And it will reply to you if the state of pin 2 is 0 or 1, low or high. If you want to use analog pins, you can do analog write 03. So I'm doing analog write on pin 03. And I'm going to write the value 255. So analog write commands in Arduino work with bytes. So I'm writing here a full byte of ones. Or I can do, like, for example, analog reads on pin 2. So this is the idea of the string we are suggesting. If your application on the client side sends to the board this kind of strings, you can simply use this project here, and let me show to you guys, file open. You can use this project here to download, compile and download to your Arduino, and then you won't have to worry about the C code on Arduino. 1 second, please. Here we are. Here we are. So we went from the very same code that comes with Arduino, and we added a little bit more code, like here, for example. You see, here I'm testing if the first letter is digital or analog. So if the first letter is digital, you want to do a digital. Read or write, I don't know. Let's see. Let's check the second character. So if the second character is W, you want to do a digital write. If the second character is R, you want to do a digital read. So we have a couple of tests here that makes it possible for you to just compile this project here, upload it to your Arduino, and now you don't have to worry about the side, the Arduino side. You can just worry about your application side. And here's the code. It's fully available for download. Now you can just download it, compile, and upload to your board. And we can like do some things. And let me show you again here. So let's see the board here again. And let me open my QuickTime Player again. So I'm going to close the lamp example, and let's say we want to play with the light sensor. You see, that's the value the light sensor is showing. I'm going to put my hand on top of it. You see the value is decreasing, and the color is darker on my cell phone. Let me see. Let me show you my cell phone here. See, you're seeing the very same information. And I can also turn on the light on my cell phone, and if I apply now the light, you see here the value is very, very high, but I can then use my hand to decrease it very fast. You see? So this is the kind of thing you can easily perform without having to worry about any code in the Arduino side, because we have provided to you guys this very simple block of code that you can just compile and upload to Arduino. Then if you get better and if you decide, you can then make it better or change this code as you want. Okay, hope you like it. Here you can find my email, and please subscribe to my YouTube channel. On YouTube, just search for Victor Fernandez. I have plenty of videos showing a lot of stuff there. And here you can find me on YouTube and Instagram. I'm open for questions, and thank you all very much.